this car has two different demos. So the first one is perception only, and the second one is the more futuristic use of large language model in the car. So we have a large language model running in the car on the edge on one of our chips. So it's on CV3. And last year we did autonomous driving. This year we're just doing L2, so not L3 but L2, with a reduced sensor suite. So just 6 cameras and 5 radars. We added the VLM, so it's a large language model that helps us to solve corner cases. So your perception system will be doing the job for 90% of the time, 99% of the time, but there will be cases in which you have to solve some ambiguities. And for example, when you have a vehicle which is stopped in front of you and you approach the vehicle, you will never know whether it's okay to overtake or just wait, because you need to understand that from the scene, from the scenario. For example, if the vehicle is a broken down vehicle, you need to overtake. If the vehicle is in a line, you will not overtake. So you need to understand the situation, assess the situation, and then decide the maneuver. And this is where the VLM comes into play. Okay. And what we're doing now is that we're putting the VLM, so the large language model, which runs in the car, it's not connected to the cloud. Right. It's just running in the car, and the AD stack, everything on one chip, so one CV3 chip. So this is what we're doing right now. Okay, so I think we can start. So I will show you on the monitor. You can see, our car is the black one, and it's moving as we are moving, and we are reconstructing what's around us with the cameras. And remember that from the frontal part we only have one camera, and in the back we only have one camera, plus the fisheye cameras, which are short range. So with all this information, we reconstruct the world around us, so the road in front of us, in the back, on the sides, and we get objects like you see the vehicles are blue squares, blue rectangles. The yellow dots is the structure, road structures, such as the posts, the fences, and stuff like that. We have also objects, different colors for different objects like pedestrians, motorcycles, and other road players. Okay, I'm driving slowly because the traffic light is red. So this is the VLM that kicks in and sends information that now it's just displayed as a text line on the monitor. But then we will be using that for the planner. So the planner will be connected, and the VLM will give suggestions to the planner. So we'll specify the next maneuver, because the VLM is something which sits on top of everything, so has a kind of broad view of the situation, so have a higher level vision of the situation. So now we're again moving. You will see that we are reconstructing the road around us. We are able to pick traffic lights, the color of the traffic light, of course, traffic signs, and when there are many traffic lights, for example in this case, we can select the one which is referring to us. And for example, here on top we have a green light, and we have a green light here for us. So when there are 3 lights, one was red to green, the one for us was green. Okay, so we are in kind of low light situation because it's night right now, but you can see the image there is the image that is used for the perception and for the VLM. Other nice structures are the gray area around the road. So dark gray means non-drivable space. We have a pedestrian crossing us, and if I zoom in, you can see the pedestrian. You can see another pedestrian there. It's walking on the sidewalk. Okay, so light gray means drivable space. Dark gray means non-drivable space. Okay, picked up the red light in front of us. This is the red light. I'll show you what happens if I remove the map that we are using. So in this case, you see we can detect lanes on the left side of the road, on the right side of the road. It's pretty nice. If I remove the map, this is what we can get just by one camera. So one camera can detect the road in front of us, that's for sure, and a little bit about the road on the other side, but nothing on the right hand side because this is not visible. But if I turn the map on, I'm using the map right now as a seed for the perception. So you can see that we can get all the lane markings, road, and the lanes on the other side of the parking spot. So we're stopping, and the VLM will kick in and tell us what's happening. Driving slowly because the dark outside and visibility is low. So it's telling us what's happening. So the VLM will be driving slowly here. Okay, so everything, so the VLM and the stack is already working on CV3. So CV3 is the engine. Okay, now there's another situation with a red traffic light. We pick the red light. We're slowing down, stopping, and maybe now it's not so useful because you know that we are a red light because we have picked up the red light there, but we will be using this way of interpreting the scene in a better way when there's ambiguity. So when you don't know what to do, you need to choose between overtaking or not, or just wait, and the LLM will kick in and will tell us what to do. Okay, so we're in a pretty dark situation here. You can see from the image there, but we're still able to detect all the lane markings. Actually, the both dots here, the other vehicles. So perception works pretty nicely, even if we have just one frontal camera, long-range camera. And we're doing that because some customers asked for a reduced sensor suite, because last year our L3 system was using 18 cameras, and this year we're just using one frontal camera. We have some pictures for you to see of our other corner cases that we found. And for example, in this case, there were pedestrians on the side of the road. This is Parma, Italy. There were pedestrians. Actually, this is a bus stop, and they were waiting for the bus. And we were asking the LLM whether it's safe to drive there. And the LLM said, well, yeah, there are no pedestrians which are showing the intent to cross the road, so it's safe to move. So a normal perception system would have given you just the presence of the 10 pedestrians. There are 10 pedestrians on the road. But with the LLM, it understands that pedestrians are just playing with the smartphone, waiting for the bus. It's a bus stop. So it gives you a higher level interpretation of the scene that is useful if you need to make a decision like drive or slow down or whatever. And other corner cases that we found, for example, this one is a vehicle which is parked in front of us, and we're approaching that car, that van, and we don't know whether we can overtake or not. And the VLM is so smart that understood that the vehicle had the door open, and it's a delivery van, so it's pretty likely that this is stopped just temporarily, so we can overtake that. So this is the use that we're doing with the VLM.